Hello everyone and welcome back to this next lecture. So in the previous lecture I had described a little bit of theory behind how the Ethereum virtual machine handles low-level transactions. So in this lecture we're going to actually see it in practice. So this is the remix ID with the ownable example contract that we had written to demonstrate the ownable contract available with the Open Zeppelin collection. So now to get started with this, first and foremost, since I'm starting afresh, it's important that we compile and deploy it. So let me go over here and compile ownable example. And we get the usual warning because it doesn't like this particular statement. That's perfectly fine. So then we come over here and we will deploy it. So in this case, I'm not really going to fret too much about the usual example, that is the parents creating the contract for the child. Let's just pick out any one address. I'm going to pick very first address, account number 1. And let me come over here, put it as the initial owner, and I will deploy it. So if you come over here, you will see that this deployment has been successful. And if you come down here, you will see that this contract has now been deployed. And we see the usual thing, that is we see the functions, these are the public functions, and there is a low-level interaction. So if we can collapse this, we come down to low-level interaction. And we've already seen that if we want, we can always send some money. So we can just put ether, and let's just put 10 ether, transact. This should be a success. Our balance decreases, and now our account balance decreases rather, and the contract balance increases by 10 ether. So this is all very common. Now the question is, how do we do low level interactions? So for in this case, supposing for example, I wanted to call this owner function. So let's first do the owner function as a normal interaction. So for example, here I'm saying I'm selecting the owner, coming down here and calling it. And this confirms that the very first account is the owner of this contract, which is only expected. So let's say we want to now make this owner low level call using it. Now to give you an idea of what I'm going to do, let's come over here and let me just close down access control for a minute and let's go to ownable. So in ownable, we have this owner public method that returns the address, which is the owner of the contract. Now, if I want to code this, that is, if I want to transfer this into a call data, what do we need to do? We need the function signature and any arguments. There are no arguments. So all we need is the function signature. So let's go over and do that. Let's come up here and I will show you two methods to do this. So I will show you the KCAT 256 online tool. Let me come up here and open it. And here I'm going to just copy paste the method that I want to call. So as I've already told you, we just need the name of the method and any types of arguments. So this is all we have. And from this we can extract the first 8 hexadecimal characters which form the first 4 bytes, that is the function selector. Now this is one way to do it. Now I'll show you a more convenient way, because after all, you don't want to be counting the number of hex characters and things like that. That's only going to invite errors. So let me come up here and show you another tool, and that is ABI encoding. Now you can pick out many of them. There are several methods. I will just pick out the very first method. So this now allows you to encode any method that you want along with arguments and gives you the necessary call data. So this is a very convenient method or very convenient tool that you can use. So in this case, it shows you what are your, this is how you construct your call data. So first you have to select what is a function. So there are now either one is a constructor or it is your function. Now in this case, it is my function because this is a special function which is owner. So here you have to see what it says. It says enter function name without arguments. And here you must enter only the name of the function. So you cannot enter these brackets, parentheses rather. It must be only the name of the method. Now there are no arguments. So that is it. Now, you do not have to worry about the actual structuring. That is the advantage of using this tool. It takes care of everything for you, and we will see that very soon. So all we have to do is put this owner, and if you come down here, you will see it automatically gives you the encoded data. And if you compare this with what we get here, you will see it is identical, right? So this is a very convenient tool which gives you the final result, and you do not have to start extracting bytes and bits from the result. So I would always recommend, when you're creating call data, use this tool and do not go and try to do it on your own. So let me just copy this over and come down here, and now we will try the low level interaction. So we've tried the remix method, or rather the remix interface, for calling this owner method. Now let us try to pass a low level interaction. So if I come down here, you will see here I will remove this value because now we don't want to give any value. I'll put it as 0 because we are just asking for the owner. We don't have to pass any ether to it. So I'm going to come and paste it, but this is not enough. Remember, this is a hexadecimal value. So you must put 0x before. If I only put this value, this is not acceptable. You must clearly specify that this is a hexadecimal value by putting 0x before it, right? So this is something you must remember. Now, this should be sufficient, but if I click on this transact button, I will get an error. So let me click on it, and you see here there is an error. It says that the fallback function is not defined. Now this is very specific to remix ID. You do not need a fallback function. That is not necessary. It is not mandatory that every contract must have a fallback function. However, when you're using this remix ID to interact with a contract through low-level transactions, if you're going to start passing call data, remix ID does not like it if the contract doesn't have a fallback function, right? So therefore, if you want to do low-level interactions with remix ID, you must ensure that your contract has a fallback function. Now in that case, what I'm going to do is I'm just going to come over here. Let me just collapse this for a minute. And let's come over here and add this particular fallback function. So the fallback function is very similar to the receive method. So let me just go and add it just next to it. So I will call this fallback. It is also an external method because it cannot be called from a contract. It is only to be called externally, right? Either through something like Remix, or through a wallet, or through React or Node.js. So I'm going to just put external, and let me just put payable just for the sake of it. And I will put a method. Now the question is, what do you want to do? You can leave it blank just the way we did it with receive method. But remember, what is the purpose of the fallback method? The purpose of the fallback method is it is executed when everything else fails. So now the question you need to ask yourself is, do you want an empty method which will just pass through? The answer is quite obviously no. In our case, if no other method was found, we would like to revert with an error. We don't want to just pass it through because that's not a good practice at all, right? You would like to say there is an error. So let me go and define a new error. I'm going to come down here and say error, fallback error, right? Just a fallback error. Just say that you should not be here. That's all. So let me copy this, come down here and revert this particular error. So basically I'm saying if you've reached here, then obviously something went wrong. Here is your error. So now that we have this, let's come back here and compile it. And we get the usual warning, so we can forget about it. Let's come down here. Let me delete this deployed contracts because I like to start with a clean slate always, right? And I'll delete this transaction list as well, so that we have a clean slate every time we start. So again, I'm going to copy this address. We have 90 ethers, so we are good to go. And let me deploy it again. So again, I'm just pasting this first address, the address of the first account, into the initial owner and I'm deploying it. So let's come up here and we'll see that this latest one is also successful. So if you come down here, you will see now there is this deployed contract. So let me expand on it, and just for the sake of it, let me call owner, and you'll see it confirms that the first account is indeed the owner of the contract. So let me come over here and copy it again. And now let me come to this low level interaction. So in the low level interaction, I'm going to again paste it, go all the way to the beginning and add 0x. Whatever you do, do not forget to add 0x to a call data, because always it is a hexadecimal value. So now that we have done this, let me come up here. Actually, let me just clear my console so that I have it as a fresh. Again, it should be a fresh, what do you call, console, so that we can clearly see what's happening. And now let me click on transact. And now you see it was successful, right? So we have now called this particular method owner using the function selector only. And the reason is it doesn't take any arguments. So let's go and open on this and see what's happening. So you see these are all the usual transaction status, so on and so forth. This is the cost. And now this is the output. You see the output also comes in a similar format. That means it is a 32-byte output, right? And since the address is smaller than 32 bytes, therefore the left is all padded with 0. Now here you will see there is a decoded output, and this output gives us this value, which is the address. And if you compare this with the address of the first account, you will see it's exactly the same. So we have got exactly the same result from a low-level transaction. Now, just to confirm this, let's now make a slightly more complex transaction, because this is a very simple function. Let's transfer the ownership to another account. So for instance, let's say I want to transfer it, sorry, not this one. Let me transfer it to account number 2. So to transfer it to account number 2, I'm going to now come over, again use this same tool, because like I said, don't try to use kcat256 and create the call data yourself. It is very error prone, because remember, we are dealing with 32 bytes and so on and so forth. That's asking for trouble. So here again, I'm going to call the transfer ownership method. So let's just copy it so that I don't make any typos. And here it's very important to remember, any typo, even a single character or an unintended space, is all it takes for this to fail. So make sure you copy things rather than write on your own. That is always a less error prone method. So I'm going to paste this here. Now this takes an argument, because I have to pass the address of the new owner. So now the question is, now comes an argument. So I'm going to say click add argument, and it now gives me a list of arguments. First, I must put the type. So you see these are all the types that you can choose, right? See the collection that has there. Pretty much everything is possible. So I'm going to click on address, and now we have to copy the address of the second account. So I'm going to copy this, come over here and paste it. So once we paste it, you see here automatically it has encoded, it has provided the call data, and it is exactly the same as before, right? You will see this is the function selector, and I will leave this to you to verify using this kcat256 online tool, right? Using the function selector, put the function selector here and verify for yourself that the first 8 characters are indeed what we are getting here. And the remaining bit is simply the argument, which is the second account. So again, I'm going to copy this over, come down here. Now I'm going to switch over back to the account number 1, because transfer ownership can only be called by the owner of the account. So let's come over here, and now I'll delete this. I'll add 0x in the beginning, because now we have a long call data, and I'll paste it, right? So you see this is the entire call data. This call data contains a function selector, and it contains a 32-byte argument. So with this, let's come down here and click on the transact button, and you'll see again we have got a success. So let's come down here and see what's happening, and you will see that it is exactly doing the same thing as before. You see, this is the decoded input. It is saying that this particular method is giving us a new owner. This is the address of the new owner. And the decoded output, here you see this is the logs, because it is saying that an event ownership transfer, or rather ownership transferred event has been emitted. And the ownership has been transferred from this address, which is the address of the first account, to this address, which is the address of the second account, right? So now to actually confirm that this has indeed happened, let's come up here and call this owner method. So let me come down here and call owner method, and you'll see the address has changed. This is now the address of the second account. So we have now used low-level transactions to determine who was the owner of the account, and also to transfer the ownership of the account from one account to the other, right? This has all been done through low-level transactions. And you have seen how this can be done through a brute force method using the KCAT 256 online tool, or using this ABI encoding tool, which can also be found through several sources online, where you can convert even very complex methods into call data. And this call data can be very long. Like I said, it can have any number of arguments, and all these arguments are simply going to be 32 byte values that are concatenated together. So this was a demonstration of how we can work with low-level transactions using Remix ID. Only one thing you must remember: if you want to use low-level transactions using the Remix ID, you must define a fallback function. Remix ID does not like it if you're doing low-level transactions without a fallback function. So go ahead, try this on your own, play around with this, because this is a very useful thing to know if you are serious about becoming a blockchain developer. And this is also a concept which will be useful going further in the later sections when we start doing low-level interactions through our contracts themselves. If any of this was still not clear to you, please post in the Q&A forum and I'll be happy to help you. Otherwise, I will see you in the next lecture. Thank you so much for listening, and see you soon. Goodbye for now.